one for AI, and our reasoning is that we started building on other chains and then run into problems that we couldn't solve and decided to build our own layer 1 for this one that's optimized for AI use cases. Yeah. Okay. Is it better? Not that much? Ah, yes. Yeah, I'm gonna briefly go over what we're doing, and I would like to focus mainly on how to build it. I will show some code examples and do some live demo. Yeah, so what you can build on us is some of these examples. It's also linked on our docs. So some of the AI gamings, economics, agents farms, and trust and transparency for AI. So you can actually see on the chain what's going on, how is this logic working. We have shipped some of the examples as well, fully open source, what we have built. So first one is the obvious one, which is like getting started one. On-chain ChatGPT, you can chat with it. You can see the front-end code, what's needed, the Solidity contracts, and the script, how to call it out. We created an AI game as well, based on Vitalik, which is a fully dynamic game. So each game is fully unique. It's generated by LLM. So like, what's the environment in the game? What's the actions can happen? It's like a battle game. You have to fight, and also fully open source. So if you're building, you can see how it's built. Generative AI NFTs, the same thing. It's fully open source. You can check it out. And also AI agents, which is essentially one LLM is one smart contract, and it can interact with other smart contracts. Yeah, and this is explanation in here how it works in the first phase of our network. We call it trusted execution enclave. So this is completely separate part of the CPU, essentially, on the computer that's isolated from the rest of the machine. So, and you can cryptographically attest this, that whatever is running inside, you can completely verify that it's running exactly as it should be. And here's the demo. You can try it out immediately. You need to have the MetaMask, so everything you do in here is a specific transaction on the blockchain. And there's a small image as well, how it works. So you have your smart contract. It's like any Solidity smart contract. All your existing tools work on EVM. And you're calling our Oracle contract, which then afterwards, after it's done computing, it answers back to your contract. And the Oracle itself is in the execution enclave, as I mentioned. And you can see also these attestations and how to verify. This is also open source on GitHub. So if you have more questions like how to verify this, it's up there. I will maybe jump into the quick start. Maybe the white screen is better. Before you can get started, so this is our quick start as well. I'm not doing anything secret. It's all up here as well. You need to get new wallet, preferably new wallet. You can use our existing wallet as well if you want. But you need to first get the Devnet tokens. So you have to log into our Discord and get it from there. You also have to set up a new RPC if you're using MetaMask, but it's also like linked on the website. And after we have this ready, we have the repository in GitHub, so you can see what's inside there. I have it already cloned in here. Well, maybe first look into the quick start contract, just to give you a brief understanding what it is. So it's a Solidity contract, quick start. It's a constructor. As you saw from the previous image, you need to interact with our Oracle contract. So you need to have the address of this Oracle contract. You can set it up however you want, but this is just one way to do it. You also want to make sure that only the Oracle can call back your smart contract, because otherwise, like, anyone can call it and inject rubbish inside or hack you. And how it starts, initialize the interaction. You call this function, whatever is your input. So this is like just a text. And this one calls our Oracle. So it works through the interface. And the message goes in here. So this is just one of the function calls. We support a couple of other ones as well. You can check it out from the docs. And if you call this out, then your transaction is done. It's an asynchronous operation. So the Oracle in the backend does its job, generates it, and then calls back your contract. It calls back this function, and then the response is saved to the contract. Of course, you can do anything that you want in here. You can have your if-else sentences.
Any like time constraints, like similar to the Oracle peak price here? Just to make sure, like,
so
the latest code. How can I make sure like that?
So the question is how to make sure I got the latest call. Yeah. This is up to you to design, to be honest. So in here, as you can see, it's just last response. You probably maybe want to have like an array. Yeah.
Similar to the peak price Oracle.
Yeah. So the question is like how to understand which callback was made. This is for the purpose of the demo. Just essentially have this one boolean. It's set or not. But in reality, you probably want to maybe introduce your own data structure, an array. You can set it as with an ID. As you can see, the first parameter is the run ID. So you can use this one to track like which is the call and which is the response. And you can, of course, have like more complicated data structures, maybe like nested classes and whatnot. Yeah, perfect. I'll maybe quickly show how to run it as well. In this one as well, we have the .n. In the .n, I will show you what I have inside. So my private key, you can copy paste this. Which you need to add in there, and wait, it's the wrong .n, sorry. Yeah, this is the one. So the Oracle address, you need to understand what's the Oracle, and your private key. We have two different ones in here. One of them is for your actual own blockchain, but if you want to run the local blockchain, want to use the different keys in there, it's just for this reason, but you can most likely just use the same ones. Have the .m set up. You need to, of course, install your dependencies and deploy quick start. It's just a simple script. Essentially, we're using the ethers.js. We're getting the Solidity smart contract code, putting into Oracle address, and then just deploying it. Pretty straightforward if you have done this. Sorry, I already showed the. Yeah, I mean, this was my example I just showed. Yeah, all good. It's compiling the contract and doing the deployment. And yeah. It's working. Yeah. So you get your contract address. And I'm setting it in the terminal variable. And then you can call this out. So this quick start is image generation model, so using DALI in the background. And now I can call this contract out. It's asking for the input. So this is sent to this quick start contract, as I showed, and this is calling out the Oracle contract. And now the Oracle in the enclave is seeing that someone is requesting a job to do. Does this compute in there, generates the image, and at the moment it's uploading this not to IPFS but to our cloud. But it conceptually doesn't really matter. It's just more convenient to get it up and running for the demo purposes. And now you can see that, yeah, it generated an image. Hopefully there's apes as well. Yeah, a lot of apes this time. Yeah, I have 8 minutes. So this is the first like simple example. We also have the Explorer as well. Maybe I'll show it. it logged out that there was the transaction. And now you can see the transaction in here as well. And I mean, I think everyone has used some Explorer. You can put in your transaction or your wallet address or whatnot and go there, the contracts as well. And then you can see what's happening in here. 1 minute ago, called this function. Yeah, I think we have seen these ones before. But for our purposes, we want to make it possible to build more complicated agents. We'll maybe show the vector store support. So RAG is a very common technique in the AI field, which is having a knowledge base for your AI. So if you have used ChatGPT, you're asking some details of outside world. It usually doesn't know. It only knows what's inside the model. So how you can improve this is to have a database essentially with different facts, for example, or you put a book, the whole book PDF inside of it, but this whole book you cannot send to the AI immediately or like the LLM immediately. You probably need to find the correct place in the book to send to the LLM. And so this is what the retrieval augmented generation is. So it's a similarity-based search database. It's a bunch of vectors, bunch of numbers. But we have made it hopefully a bit more accessible. So on the Python side, you can put in your data. So I created, this is also in the repository as well. So we have these RAG tools. Created a simple data when I'm presenting, and I took the next one as well. So Celo is presenting. We need to make this uploaded this to IPFS so that the Oracle can access this. I have a simple script in here. It's unmodified. It's just the latest version of in our repository, and you can upload this to the IPFS, and then you get the IPFS CID back, and then you can put this while it's uploading. I will show you. This is the ChatGPT example in here. So it's a contract, and how this works is the knowledge base CID goes inside as well, so it can forward this to the Oracle to be used. Similar stuff. So if you start the chat, so first it checks like if it has a knowledge base, and if it has, it's making the knowledge base query. It's again async operation, and after this finishes, it calls back the callback function that you got the knowledge base query back. So hopefully it found this first line of this text, returns this to you, and then after you got this back, you can make the actual call to the LLM. And once this is complete, you get the callback to this function. This is one-off example, but now imagine you can have in here as well another maybe knowledge base query or another LLM query, essentially like a for loop, right? Or you can call another smart contract out that does, maybe another piece of operations, a couple of calls. Question is about can we do multi-chain? Not yet at the moment. Currently supported chains. So this is only this chain. It's at the moment isolated. We don't do the cross-chain integration at the moment. Just only the EVM. But this is definitely on the roadmap. It's asked like, okay, for DeFi applications mainly, like how can I get some more liquidity from other chains to LLM stuff, put this back to the other chain, to the trades. Yeah, so added the knowledge base. I got back the CID. I think I need to just quickly modify the previous example to deploy. Now deploying this contract I just showed, the ChatGPT one with the knowledge base. And after this one is deployed, I can actually ask when is my presentation time and show up. Yeah, it's deployed now. So now what happens is what I described. It first gets the data from the knowledge base and puts this into the LLM call. And then hopefully it answers the right time. Yeah, 15, 20. I'm not sure why it's double. It should be just once. Yeah, that's what I wanted to show. Do you have any questions? I guess not. So that's it. We're at the booth. Yeah.
So actually, what about prices? What part was you? What do you expect in
So the question is, what do we expect and what are the prices? Yeah, we expect to see AI agents. This is what we're interested in. The prices, I'm actually not sure. I think you should visit our booth. Our product people are going to be there as well, and we can sync ideas and share like what we're interested. I think they listed a couple of ideas out as well, like what would be one of the examples. If you just want to build on us but don't have any idea, then we can suggest something as well. Yeah, thank you very much.